Hi, I'm Ethan, and this is going to be the fifth part of my 10-part Unity tutorial series. So in the last video, I covered how to make prefabs, which are these boxes over here, and I covered how to make an additional landing so that we can finally have some ground for a boulder to roll on. And I covered how to make tile textures so that your ground can have a repeating texture so that it doesn't look all stretched and weird. And in this video, we're finally going to give our game some functionality. So we're going to start to get into some coding. And to start with, I'm going to add some code so that our boxes will get destroyed whenever a boulder hits it. So to start with, we're going to need to make a script. So to do that, click the box prefab in your project window, which is right over here. So make sure that you're not clicking your. Sorry, just need to fix something real quick. Make sure that you're not clicking the boxes in your scene because you really want to remember that the whole point of a prefab is that all changes made to the prefab will be inherited by all clones of the prefab in your scene. So it's just easier and better to put the script directly on the prefab in the project window instead of individually copying it to every single crate in the scene. So to start, let's select our prefab, make sure it's selected, and then click add component. So adding a script to an object is the same as adding something like a box collider, a rigid body, or any other component that you might need. So just click add component, and then we want to click new script, and then I'm just going to name it box. So out of the frame of the screen, there's a button that says create and add. So just click that if you're following along. And here, now we have a box script that has been put into our project window, and it has automatically been added to our prefab. So to enter it, just double click, and Visual Studio should start opening up now. So in here is going to be our box class. So Unity uses C# to program. So that is going to be what I'm going to be roughly teaching in this series. Unity also uses JavaScript, but I much prefer C# as that's what I've mostly been practicing on. So just for this guide, I'm going to be using C#. Now to start with, we have a void start method. And this basically means that, well, the comment already explains it, but the void start method basically means that when the object first starts to exist, it is going to run whatever code is in here in the first frame that it starts existing in, if that makes sense. Like, it basically runs this code when the object starts the script, when this script starts. And in the update method, this script is going to run the code in this method every single frame. So it's going to update the code constantly in here. It's going to constantly run the code. So in this case, we want our box to detect when it hits an object, and we want it to detect if that object is a boulder. So to do that, we're going to need to make sure that we're not typing into our start or update method, and we want to type something called on collision stay 2D, since this is a 2D game. And I pressed tab to make it autocomplete like that, but what you should have now is something that looks like this. So this basically means that for every frame that our box's collider is hitting another collider, run this code. So that should be fairly intuitive to understand, but if you don't get it yet, then that's fine. We'll be able to show what this code does later on. So to start with, we want it to detect not indiscriminately. We don't want it to run some code for every single frame that it's hitting anything. We want it to run some code when it hits the boulder specifically. So to do that, we need to make a conditional if statement. So to write that, we just type if, and then parentheses, collision dot collider dot compare tag, and then parentheses again, quotation marks, boulder, and then some curly brackets, press enter, and Visual Studio is great because it automatically puts the curly brackets in just the right place that you need it. So now this code might look a little bit complicated, but it's actually really simple. Basically, it's going to check if the thing that we just collided with has the tag boulder. So collision collider basically means the other collider that we just hit. So basically, if the thing that we just collided with has the tag boulder, and if it does, if this entire statement is true, then run this code. So the code that we want to run is going to be to destroy the box, to just absolutely annihilate the box. So to do that, it's very simple. Just type destroy and then game object. So the game object in this specific case is the game object that this script is attached to. So now if we can hold down Control S to save this script, I'm going to minimize Visual Studio. It's going to take a while to save the changes in Unity. And now, if we press play, it's not going to work at all. And this is because our box is checking if the tag boulder is. Our box is checking if the thing that it just collided with has the tag boulder, but the tag boulder doesn't exist yet. So we want to click our boulder and I want to give it a tag so that when the box hits it, it knows that this is a boulder. So to give our boulder a tag, we want to click tag next to, in the inspector, we want to click untagged in the inspector, and then we want to click it. It's going to give a drop-down menu, click add tag. So we don't have any tags of our own yet, so just click this plus and then type a tag, so boulder. And when you do this, it's important to note that the boulder tag has not been added to our boulder. We want to click our boulder again, and then go back in the inspector again, and then finally click the drop down, and finally give it our boulder tag. So now, if we click play, hopefully this should work. It's working. Look at that. So now, when our boulder hits the boxes will realize that it is a boulder and then destroy themselves. Now this is nice and all, but it's really anticlimactic for our boxes to just disappear into thin air whenever our boulder hits it. So we want our boulder to have some sort of leftover, some debris left behind. So to do that, let's make it instantiate something. So instantiate basically means spawn, to spawn an instance of something. So we want our box to instantiate an instance of some debris particles. So to do that, I'm going to type some code again. Serialized field, game object, debris particle. So what this does is that serialized field means that this is going to be something that appears in the inspector and that we can change or modify or drag something into. Game object just means it's going to be an object in the game. And debris particle is just the name of it that we're going to reference that's going to be in the inspector and in the code. So now that we have that, we want to spawn it when we destroy our box. So if our box hits something with the tag boulder, we don't want it to destroy itself first. We want it to spawn some debris particles. So instantiate debris particles, comma, transform dot position, comma, quaternion dot identity, and then end it with a semicolon, as always. So this is a bit of a mouthful, but what this does is it's going to spawn our debris particles at the box's current position with the debris' current identity. The debris' current rotation. And then it's going to destroy our box. Now, we need to make debris particles first. So this is also going to be the introduction to particles in Unity. This is going to be a very quick and dirty introduction, but it is going to be an introduction nonetheless. So let's minimize Visual Studio again. And if we click our box prefab, you'll actually see, if you scroll down to the box script, there is a field called debris particles with nothing in it yet because we haven't put anything into it yet. So let's make some particles for our box to spawn now. So to do that, I'm going to right click in the hierarchy. I'm going to go to Effects and then Particle System. Now the first thing you'll notice is that it's black again, just like the last time when we dragged in our box at first. And this is because it's using a lit particle, a sprite default lit, and our game engine and our project has lighting, or it's supposed to have lighting. So we are going to make a lightingless material that's gonna make it look all normal afterwards. So to do that, I've already made a sort of debris for our crate. It should be in here. There it is, our plank. So to make this, all I did was I just cropped a section of the box and then made that a PNG and then just dragged it in. So it was really easy, very simple. You can do this for really anything you want. So now I want to make a material out of this debris sprite that I have. So I'm going to go to materials, I'm going to right click, create material. I'm going to name this, plank material. And then the next thing I'm going to do is actually not drag in my plank yet. I'm going to go to shader. I'm going to change it from shader to standard. I'm going to go to sprites and textures. I'm going to drag my plank into albedo over here. I'm going to change the shader from standard to sprites default. And there we go. And then now we have this plank material. I'm going to select our particle system. You can select it by either clicking on the particles or just clicking on the hierarchy. And then down here, there's a render module. So just click that. And now you see this material. Just drag our plank material into this, and boom, there we have it. But this does not look right at all. First off, it's floating. We don't want it to be floating. And second off, it's like a candle that's like spewing flames everywhere. We don't want that. So first off, we want to disable looping. This means that when our particle is spawned, it's not going to continuously spawn more and more particles. We just want it to spawn some particles in one big burst so that it looks more normal, as if a box was actually destroyed. So, by the way, if you want to look at the particles again, just click restart, and now the particles will play again. But again, we don't want it to spew out all of these candles, even like that. Spew out all of these planks like that. So I'm going to change the duration to 1. Now, duration is basically how long it's going to emit particles for, and lifetime is how long the particle system actually lasts. So now, it's only going to do that, but that's still clearly not the effect we want. So I'm going to go to emission, and I'm going to change the rate over time to 0. Now, rate over time affects how frequently particles respond over the lifetime, over the duration of the particle system. So let's say I change it back to 10, click restart, it's going to spawn 10 over the course of 1 second. If I change it to 100 and then restart, it's going to spawn 100 particles. But we don't want that. We want it to instantly spawn a bunch of debris from the box. So change this to 0, and then over here in bursts. So this is basically going to spawn a bunch of particles all in practically one go. So now all I did was click the plus to create a burst, and now if I click restart, it's going to make one big group of particles all at once. So that's looking a little bit better, but it's not falling yet. We want our particles to have physics. So let's change the gravity modifier to 1. Now, that's way better, but it's going through the floor. So we want it to collide with our floor. So I'm going to check collision. So make sure this is checked. I'm going to expand that. I'm going to change visualization from solid to, sorry, no, not visualization. Type from planes to world. And then change the mode from 3D to 2D. And then change it from collides with everything to collides with nothing for now. Now, I'm going to go into my ground prefab because we want our debris to collide with our ground but nothing else. So I'm going to change our layer for our ground from default to, I'm going to give it a new layer, ground. So I made the ground layer, I clicked out of it, and then I actually selected the ground layer for it. And now we click over here, boom, ground. So now I'm going to click back into my particle system. I'm going to go into collides with in collision, and then I'm going to select collides with ground. So now if I restart, it hits the ground and then bounces. We don't want that. So over here, change bounce from 1 to 0.1, change dampen from 0 to 0.8, 0.5. It's okay, 0.2. Yeah, so this is looking a lot better, but it's very strange for all of the debris from a box to just stand upright. So we want to give it a random rotation the moment it spawns. So to do that, click, so over here you see start rotation, click this drop down arrow, click random between two constants, and just give it some numbers like, I don't know, 313, 370. And now it's going to give it a random rotation the moment it spawns. And this is great. But now we want to give it a random size because, well, debris is a little bit chaotic, so might as well give it a random size. So do the same thing for start size. Click this down arrow, click random between two constants, change it from, I don't know, let's say 0.7 to 1.2, and restart. There we go. That's looking a lot better. I'm going to change it again to 0.6, 1.4. Oh yeah, so this is about as good as it's going to get within our time constraints. And yeah, so now that we have this particle system, I'm going to rename it. I'm going to give it a name, box debris particles. I'm going to drag it into my project window to make it a prefab. I'm going to delete this prefab. I'm going to select our box script. No, I'm going to click my box prefab, and then I'm going to drag our box debris particle system into the inspector, just like that. And finally, now, if we click play, our boulder should roll down the hill, hit the boxes, and then a bunch of particles should spawn. Now, if we click into our scene view, the particles are not despawning. Well, the particles themselves went away, but our actual particle systems are not gone. So let's change that. Click the particle prefab in your project window, and then let's see here, go, yeah, so cooling action, no, sorry, not cooling action, stop action, change it from none to destroy. So this will destroy our particle system when it's done existing. And another thing is, when our debris particles were despawning, they just disappeared instantly. We don't want that. So let's change it. So let's make it so that it slowly disappears over time. So let's see here, size over lifetime, check that box. Over here, this is a curve. If I drag this out, we can see what this looks like. It's going to grow bigger because you can see that this curve is going up. We want to change that. So select this. Now it's going to show a graph down here. I'm just going to select one of these options already. And Yeah, that's looking pretty good. We don't want it to start going smaller from the beginning. We want it to kind of stay at a constant size up until the very end. So I'm going to add a keyframe by just right clicking and then clicking add key and then dragging it. If you know how keyframes work, then this should be trivial. Yeah, that's pretty good. So now that we have that, I'm going to override our prefab. So anytime that you make a change to a prefab, but the prefab is actually an instant in the scene, you want it you want to override the prefab, which is basically means changing it, like saving the changes so that it applies to all the other prefabs. And to do that, just click overrides, apply all. Now if I delete this, and then every single box should hopefully spawn the particles, then the particles will slowly go down over time. Look at that. So that was it. Today, we added some functionality to our boxes where they get destroyed, and then they also spawn some particles in return so that the player has some more solid feedback for when the boulder runs into props. So we can do this for pretty much anything that our boulder runs into, like say houses. So in the next video, I'm going to be covering how to make a movement system for our boulder so that we can have more control and turn it into a real actualized game. So thank you for watching.